Hello, my name is Jose Rodriguez, Technical Service Instructor. This video explains the trolley systems in the electric off-highway truck Caterpillar. Electric drive off-highway trucks can be equipped with a trolley attachment, which uses electrical energy from a local power grid to power the electric drive motors and propel the truck on a haul road grade during a mine haul cycle. Dedicated trolley substations. 1. Convert AC power to DC power, rectify cation. A typical substation supplies 2,500 volts, can handle 10 megawatts of power and feeds approximately 0.5 to 1 kilometer, 0.3 to 0.6 miles, of trolley line. 2. Which will support up to 2 trucks at a time. Trolley lines, segments, are insulated to limit fault currents. The truck engages and disengages the trolley line via 2 pantographs. 3. While traveling. While on the trolley line, the truck's traction power is supplied only by the trolley and the engine speed is decreased to 1,300 revolutions per minute to support only parasitic loads, standby power, and fuel economy is increased. Trolley structure and mounting. 1. Trolley cabinet and platform welds, and cabinet mounting bolted joints. 2. Welded joints in trolley mounting structure and pantograph, and all bolted joints. Truck operation on trolley. While connected to the trolley system, the electric off-highway truck can nearly double its speed. The steering, throttle, brakes, and shift lever functions remain the same. Travel direction is uphill and the truck bed must be at least half full. Traveling uphill empty will result in increased carbon brush wear due to the increased speed. When entering the trolley system, trucks must be traveling at least 8 km per hour, 5 miles per hour. To enter the trolley line, align the truck siding paddle with the trolley line. Press trolley switch in the cab to engage the pantographs with the trolley line. When the pantographs engage the trolley line, voltage is measured and, if within range, contactors in the trolley cabinet close. Voltage that is out of range will send a fault message to the monitoring system. For trolley line operation, the engine speed is set to 1,300 revolutions per minute. The shift lever position for trolley line operation is drive or low and the speed is controlled by the throttle pedal. Line status signals must be observed, which indicate when segments of the trolley line are energized or de-energized. If the truck speed decreases below 8 km per hour, 5 miles per hour, disengage begins taking 5 to 8 seconds as follows. Engine speed increases to high idle. Contactors open once power drops to a certain level. Rapid disengage is initiated taking 1 to 2 seconds if the following occur. Service brakes or retarder are engaged. A serious fault occurs such as overcurrent or ground fault. Pantograph becomes disengaged. System voltage drops such as too many trucks on the trolley line. When exiting the trolley line, press the trolley switch in the cab to disengage the pantographs with the line. At this point, engine speed increases, contactors open, the pantographs lower, and the truck returns to engine diesel power. In the event of a level 3 event code, stop the truck and shift into park. If the pantographs will not lower, shut down the engine to bleed the hydraulic system. Contact mine personnel to have the substation de-energized and grounded. Trolley attachment components. This image shows the additional components that are installed on the 795 FAC truck with a trolley attachment. Electrical power from overhead wires FLOWS through the trolley system via the pantographs, 1, which are attached to a mounting structure, 2, at the front of the truck. The 2 pantographs are mounted on the top of the trolley structure. Hydraulic cylinders raise the pantograph into position to contact the overhead lines. The trolley switch, 3, located on the center console in the cab, sends a signal to the drivetrain ECM to start the engage or disengage sequence. The trolley cabinet, 4, on the right side of the truck contains a voltage sensor, current sensor, pilot relays, bus bars, dampening resistor, cooling fan, Phi-LTER, contactors, and an inductive Phi-LTER. The inverter includes an integration kit, 5, to provide a DC input point for the trolley voltage. Control and monitoring of the trolley components is integrated into the existing CAT electric drive control ECMs, therefore no additional ECMs are required. Electronic control system. This illustration shows the components that provide input to the drivetrain ECM and the output components that the drivetrain ECM controls. The drivetrain ECM also communicates with the motor control 2 ECM, 12, over the CAN A and CAN B data links, 16 to 17. The input components are left pantograph position switch, 2, right pantograph position switch, 3, DC contactors, 4, trolley switch, 5. The cab trolley switch is a momentary toggle switch which sends two inputs to the drivetrain ECM as a fail-safe feature. The ECM must receive two ground inputs to engage the pantograph. The ECM will disengage the pantograph when the ECM receives an open input from the trolley switch. The output components are accumulator bleed solenoid, 6, speed solenoid, 7, direction solenoid, 8, pilot relay 3, 9, pilot relay 4, 10, cooling fan motor, 11. Inputs to the motor control 2 ECM are cabinet temperature sensor, 13, current sensor, 14, voltage sensor, 15. Pantograph components. The pantograph base frame, 7, provides the mounting structure for the hydraulic cylinders, 10, and buffer spring, 9, as well as the lower arm, 6, and the thrust rod, 8. The rod end of the hydraulic cylinders is connected to the lower arm. When the cylinder is retracted, the lower arm raises the upper arm, 5, and articulation frame, 1. The articulation frame arm supports the secondary suspension, 3. The thrust rod pushes the upper arm when the pantograph is raised. The push rod, 4, stabilizes the articulation frame arm when the pantograph is raised. Spring boxes on the secondary suspension dampen the movement of the collector head, 2, and ensure good contact with the overhead line. The collector head contacts the overhead line to collect current. Pantograph pressure manifold and accumulator location. The pantograph pressure manifold, 1, is located below a cover at the top of the platform near the base of the pantograph mounting structure, 2. The pressure manifold controls the oil flow from the steering priority valve to the pantograph cylinders. An accumulator, 3, is mounted to a bracket attached to the right vertical frame rail. The accumulator stabilizes the pantograph hydraulic system oil pressure and provides oil if the engine stops or the steering pump fails. Pantograph pressure manifold components. The needle valves, 8 and 9, on the pantograph manifold can be adjusted to control the pantograph raising and lowering speed. Additional components located in the pressure manifold are accumulator bleed solenoid, 2, relief valve, 3, pressure regulator valve, 4, direction solenoid, 6, speed solenoid, 7, left cylinder test port, 10, right cylinder test port, 11. The needle valves, 8 and 9, on the pantograph manifold can be adjusted to control the pantograph raising and lowering speed. Additional components located in the pressure manifold are accumulator bleed solenoid, 2, relief valve, 3, pressure regulator valve, 4, direction solenoid, 6, speed solenoid, 7, left cylinder test port, 10, right cylinder test port, 11. Pantograph hydraulic system, disengage. When the trolley switch is moved to the disengage position, a signal is sent to the drivetrain ECM. The ECM de-energizes the direction solenoid, 6. After a slight delay, the speed solenoid, 7, is de-energized. Left illustration. The direction solenoid directs oil from the rod end of the hydraulic cylinders, 12, through the needle valves to the tank. The weight of the pantograph extends the cylinders. The pantograph lowers at a controlled rate when the oil flows to the tank through the needle valves, 8 and 9. For the short time, the speed solenoid is energized by the drivetrain ECM during disengage. Right illustration. The speed solenoid directs oil from the rod end of the cylinders to the tank. The oil bypasses the needle valves to extend the cylinders and lower the pantograph at a faster rate. Therefore, the pantograph lowers quicker when exiting the trolley line. The pantograph position switches, not shown, will notify the drivetrain ECM when the pantographs are fully lowered. Cabinet components. These images show the main components in the trolley cabinet, which transfer power from the pantographs to the DC bus in the inverter cabinet and also cool the trolley cabinet. Outside air flows through the air filter. 1. To the cabinet cooling fan. 2. The cooling fan circulates air through the cabinet to cool the cabinet components. The cooling fan motor, which drives the fan, is controlled by the drivetrain ECM. The current sensor, 5, and voltage sensor, 6, monitor cabinet current and voltage and send corresponding signals to the motor-controlled 2 ECM. The reactor, 3, and dampening resistors, 7, are filtering devices which limit the transient current as trucks enter and exit the trolley line. The motor-controlled 2 ECM monitors the reactor temperature by using resistance temperature detectors, RTDs. RTDs are sensing elements consisting of a deposited film element of platinum. The element's resistance increases with temperature in a known and repeatable manner, providing linear outputs with respect to temperature. The reactor RTDs are connected to a terminal block, 4. The drivetrain ECM sends signals to the pilot relays, 8, which close the high voltage contactors, 11. The contactors connect the DC source power from the trolley line through bus bars, 12, and high voltage cables, 13, to the truck inverter cabinet. 2 10-amp circuit breakers, 10. Protect the pilot relays and main contactors. A 20-amp circuit breaker, 9. Protects the cooling fan. Trolley current flow. These images show the path of current flow from the overhead lines, 1, through the pantographs, 2, and trolley cabinet, 3, to the inverter cabinet DC bus, 10. When the contactors, 5 to 6, are closed, the pantographs are connected to the inverter cabinet DC bus. When the pantograph is not connected and/or the contactor is disengaged, the DC source from the trolley line is not connected to the DC bus, and the diesel engine generator rectifier provides the power for the DC bus. The switching between diesel propel mode and trolley propel mode is performed through the drivetrain ECM, which raises and lowers the pantographs and disengages the contactors, based on sensor input and drivetrain software strategies. The end.